To finish our problem, we need to put ax squared plus bx plus c in the form a times x minus h squared plus k. Remember, we are doing this so that x only shows up in one place so that we can solve for it. To put ax squared plus bx plus c in the form a times x minus h squared plus k, we need to figure out the values of a, h, and k so that ax squared plus bx plus c equals a times x minus h squared plus k. Just as we have been doing when we knew the numbers a, b, and c instead of leaving them generic. So as with our examples, we distribute the right-hand side, which gives us the same thing as it always has, ax squared minus 2ahx plus ah squared plus k. And again, like our examples, we want to find a, h, and k so our coefficients are equal. In particular, our coefficient of x on the left must be our coefficient of x on the right. So here we need a equals a, which shouldn't come as any surprise, although maybe we should have made these different letters to begin with. And we'd probably expect this anyways from doing our examples. We also need our coefficient of x to be the same on both sides. So b has to equal negative 2ah. And finally, our constant has to be the same on both sides. Our constant c on the left has to be our constant ah squared plus k on the right. Now we want to solve for h. We can do this by dividing by negative 2a in this equation, giving us b over negative 2a equals negative 2ah over negative 2a, which is just h. And we can rewrite the left as negative b over 2a. So we have found that h equals negative b over 2a. Now for any polynomial ax squared plus bx plus c, we can find h as negative b over 2a without doing these steps over and over again. Now plugging in what we just found for h, we get that c is a times h squared, which is negative b over 2a squared, plus k, which is a times negative b over 2a times negative b over 2a plus k, since that's what it means to square something. And we can simplify this, because our a cancels with our a. And we can simplify this, because the a in the top cancels with one of our a's in the bottom. And then negative b times negative b is b squared, and 2 times 2a is 4a. And we still have plus k on the end. But we want to solve this for k, which we can do by subtracting b squared over 4a. This gives us c minus b squared over 4a equals b squared over 4a plus k minus b squared over 4a. And since b squared over 4a minus b squared over 4a is just 0, we're just left with k on the right. So we found that k equals c minus b squared over 4a. We can, however, simplify this a little bit. Because we want to subtract one number from the other, but one's a fraction, we need to get a common denominator. To do this, we'll multiply c by 4a over 4a, giving us 4ac over 4a minus b squared over 4a. Now that we have a common denominator, we can combine these to 4ac minus b squared over that common denominator 4a. So although they're very messy, we have now found a, h, and k. And we can conclude that we can rewrite the polynomial we want in the form ax squared plus bx plus c equals a times x minus negative b over 2a, our h, all squared, plus 4ac minus b squared over 4a, our k. Let me point out that while this has been very messy so far, it will get better and we'll have a very beautiful conclusion at the end.